All right, here we go with some substitution examples from section 4.5. All right, as we look at this first problem, we would like to do it by power rule, but the trouble is that's not just a variable squared, but a whole expression. Because of chain rule, we can't just address it by power rule. So what we do is we make a substitution. We wish it was a variable squared. So we say, well, let u equal 2x minus 3. If we do that, it will indeed become u squared. However, you have a dx. You can't have u squared dx. That's not legitimate. You can't deal with that. So here's what we do. If u is 2x minus 3, then du, or the derivative of u, is 2. Now think of it this way. It's like du over dx is 2. I'm going to move the dx over. Again, du dx would be 2. I move the dx over. All right, so if I had 2dx in my problem, I could replace it with du. So what I do is I create that. I insert a 2. But if you put a 2, then you have to put a 1/2 so that you're not really changing anything. So now we have 1/2 the integral of u squared, and then 2dx gets replaced by du. Now that is something I can integrate by just straight power rule. So you have 1/2, and then you've got u cubed divided by 3. And then you go ahead and multiply the 1/2 and the 1/3 to get 1/6 u cubed. Finally, you put the 2x minus 3 back in. So you have 1/6 2x minus 3 cubed plus c. Let's look at another. Suppose you've got this expression. Again, we would like to do u to the 7th. That's what we would like to do because we could do it by power rule. Well, if we're going to let u be 6 minus 3x, then du dx would be negative 3. And I move the dx over here as opposed to putting it down below. So I have to create negative 3 dx in my problem. And so I'm going to insert a negative 3, which means up front I insert a negative 1/3. I call those fudge factors. So now we have negative 1/3 integral u to the 7th, and then negative 3 dx becomes du. We make that replacement. Now we can do power rules, so negative 1/3 u to the 8th over 8. Go ahead and multiply the fractions to get negative 1/24. Then you have u to the 8th, but now let's go ahead and put 6 minus 3x back in for the u to the 8th plus c. All right, let's try another. Now suppose you have the integral of 4x cubed plus 1 to the 6th dx. You would assume that it's a good idea to let u be 4x cubed plus 1 based on our last two examples. But if you do that, du is going to be 12x squared dx. Now that would involve inserting a 12x squared and a 1 over 12x squared. That is not okay. And the trouble is that you're inserting a variable. You cannot insert a variable and then insert a variable expression out front because variables don't slide in and out of integral signs. So this cannot be done as a u sub. Instead, if you were actually going to do it, you'd have to go ahead and take that up to the 6th power, which would be terrible, so we're not going to do it. But we'll just make a note, can't be done by u sub. All right, let's take a look at another. How about this guy? Well, you've got the integral of x and then the quantity x squared plus 1 squared dx. Now the idea is to choose your u so that the leftover stuff in your integrand can be turned into du. Suppose we let u be x squared plus 1. So that's going to become u squared. Well, that's appealing because we could do power rule in order to integrate it. Well, what would du be if u is x squared plus 1? Du would be 2x dx. Now, although I'm not allowed to insert variable fudge factors, I don't have to insert a variable here because that variable's already sitting there. All I have to insert is a 2 and a 1/2 out front. And that's completely okay. So I keep my 1/2 out front. I've got u squared, and the 2x dx becomes du. Now I go ahead and do power rule, 1/2 u cubed over 3. I go ahead and multiply my fractions, so I have 1/6 u to the third. Again, u is x squared plus 1, so x squared plus 1 to the third plus c. All right, let's take a look at one that involves a little bit of trigonometry. How about you've got the integral of sine squared x cosine x dx? Well, again, you choose your u so that the du is something you can create out of the leftovers. Well, I could let u be sine x. If u is sine x, then du is cosine x dx. And we've got that. In fact, we don't even need any fudge factors. It's going to become u squared. The cosine x dx becomes du. And you go ahead and get u cubed over 3, or in this case, sine cubed x over 3 plus c. Note, it would not have worked for us to let u be sine squared x, because then du would have been 2 sine x cosine x dx. And then this would have been our u, and then we wouldn't have had enough stuff left over to turn into the du. So that's why this was our good choice. How about this guy? Well, for this guy, if you let u be sine x, I think you're going to see you run into trouble. Du would be cosine x dx. That would mean I'd have to insert cosine x. That's a variable fudge factor. I cannot insert a cosine x and a 1 over cosine x. Those are variable fudge factors. Those are forbidden. We can't do that. Now, if you think to yourself, well, how about we let u be x, and then du is dx? We never do this because it's actually just a waste of time. All you've done is change the letter, but you haven't actually accomplished anything. Now you would have sine squared u du, and that's no easier to integrate than what we started with. So this problem just cannot be done by u substitution. And in fact, right now we can't do this at all. There will come a time in the spring we'll be able to handle it, but not yet. Let's see, the last one for this video, let's try this guy. Again, you have to choose your u so that the du is something you could create. I'm going to start off with a bad choice. Suppose I let u be the sine of x cubed. This is not going to work for us because du is then the cosine of x cubed times 3x squared dx. Well, we've got an x squared in our leftovers, but we don't have a cosine x cubed anywhere. And we can't insert it because it involves a variable. It'd be a variable fudge factor. So that is not a good choice. Again, you choose your u so that the du is something you can create out of the leftovers. And if u is x cubed, du is 3x squared dx. You insert a 3 and a 1/3. If you're thinking, but I haven't taken care of the sine, that's not a problem because we can integrate sine. This becomes the sine of u, and then 3x squared dx is equal to du. And it's okay that the sine is still there because we can integrate sine. We get negative 1/3 cosine of u, and then we would put the x cubed in for our u, and so we're going to get of x cubed, run myself out of space here, plus c. So there you go.